The figure below shows a high-voltage distribution electricity network supplies electricity to customers from zone substation feeders via distribution transformers. Why HV and not supply LV from zone substation feeders? High-voltage distribution allows the same power to be transferred at much lower current. This significantly reduces I²R losses, conductor heating, and energy waste across the network. Supplying low voltage directly from zone substations would require extremely large conductors. Even short LV feeder lengths would suffer excessive losses, making LV impractical for distribution. Low-voltage feeders experience large voltage drops as load changes throughout the day. High-voltage feeders maintain stable voltage, with local transformers providing consistent LV supply. Long LV feeders produce very high fault currents at the substation and along the feeder. These high fault levels increase arc flash risk and place unacceptable stress on switchgear. High-voltage networks support graded protection, sectionalizing, and load transfer. This allows faults to be isolated quickly while maintaining supply to as many customers as possible.
A network is designed to allow for feeding of distribution transformers, load transfer, interconnection, backup in fault situations. Networks are designed to suit the electricity needs of the particular location. A network can be simple and consists of relatively few components, whilst other networks can be extensive and complex. There are three major types of network configurations: radial, open ring or double-end fed, closed ring. A radial network consists of independent feeders that branch out to supply electricity without connection between feeders. This is typical of long rural lines with isolated load areas. The supply security is the lowest as a fault or loss of supply will result in an outage on all customers served by the feeder. Furthermore, supply service is interrupted when any piece electrical apparatus must be de-energized to perform maintenance and service. Radial networks are used because they are the simplest and least expensive to build, and operation and expansion are simple. An open ring network starts at the zone substation and is connected to or encircles an area feeding one or more distribution transformers. Transformers can be fed from two feeders, but under normal operating conditions, the two feeders are separated by an open switch called a normal open point, or NOP. Transformers are fed from a single feeder, and in the case of loss of supply, the NOP can be closed to supply transformers from the second feeder to restore supply after the faulted section of the network is isolated. The benefit of an open ring configuration is that in the event of a fault or required maintenance, a small area of network can be isolated and the remainder of the network kept on supply. This configuration is generally found in urban or more populated areas. A typical closed-ring network configuration has two feeders permanently supplying each distribution transformer. 3 circuit breakers are used, a circuit breaker for each feeder and circuit breaker for the transformer feeder. Conductor or cable provides connection between transformers. In the case of a fault, only the 2 circuit breakers at each end of the faulty circuit trip, and no customers are disconnected. Closed-ring networks inherently deliver a very high quality of supply. However, the high cost of switchgear and protection has limited their application. Power networks. High-voltage underground electricity networks operate at 11 kV and extend from the zone substation feeder circuit breaker to the distribution transformer. Underground distribution electricity networks are normally formed by paralleling a number of ring-shaped grids. Distribution transformers are then connected to the network by T-offs.